Namaste everyone. In this video we shall discuss about a law called of sines. This is part of physics. So while discussing about addition of vectors, we will come across this law called as law of sines. The mathematical law of sines I have already written. It is r by sine theta, a by sine beta, that is equal to b by sine alpha. So this is beta and this is b. So they look almost similar, but there is a difference between them here. Actually beta is an angle and beta is a vector. We will see that. So now let's consider two vectors. So what are we going to do in this video? We're going to derive this this mathematical relationship between the vectors and their angles. And why is it called as law of sines? Because there is involvement of a trigonometric ratio sine here. Therefore it is called as law of sines. Now let's consider vector a. This is vector a, and let's say there is one more vector. Say this is vector b. This is vector b. Now the resultant of these two vectors will be somewhere here. This is vector r. So what is r here? R is the resultant of the two vectors a and b. Now let's construct a parallelogram here. Let's construct a parallelogram here. So let me label these points. Let me call this as O, and this is P, this is Q, and this as say for example S. I'm not using R here because R used to represent the vector R, the resultant vector. And let's draw QT perpendicular to the vector A. Now what are these angles? Let's mark these angles now. Theta is the angle between the two vectors A and B. So what is theta here? It is angle between vector A and vector B. Now what is alpha? Alpha is the angle between, this is alpha. Alpha is angle between vector A and the resultant vector R. Now what is beta? Let's mark this angle as beta. Okay, this angle as beta, this angle as beta. So what is beta? Beta is the angle between vector B and resultant vector R. Now how can we say this is the angle between resultant vector R and vector beta or vector B? Vector B is here, but you observe that PQ and OS are equal to each other. How can we say PQ and OS are equal to each other? Because PQ and OS are the opposite sides of a parallelogram, and we know that opposite sides of a parallelogram are equal. So therefore PQ will be equal to OS, and OS is representing the vector B. So therefore I can call PQ as a representation of this vector B, and this is angle beta. This angle lies between this PQ, which is nothing but vector B, and the resultant vector, that is OQ. So beta is angle between vector B and vector R. Now let's see how to derive this. Before we derive, observe these two angles carefully. Which two angles? QPT and the angle SOT. So I can say this angle and this angle, that is QPT, angle QPT will be equal to this angle SOP or SOT. How are we able to say that? We're able to say that because this angle and this angle, they are corresponding angles. They are corresponding angles, and corresponding angles will be equal when the two lines which are parallel are intersected by an by a transversal. So which are the two parallel lines here? PQ is parallel to OS. How can we say PQ is parallel to OS? PQ and OS are the opposite sides of this parallelogram OPQS. Therefore, they are parallel. And what is the transversal here? OP is the transversal. So since the two lines, that is PQ and OS, are parallel and intersected by a transversal, the corresponding angles are equal. Now this QPT is nothing but it is equal to SOT, and if you see, SOT is written as theta here, so therefore QPT will also be equal to theta. So I'll mark this as theta, QPT as theta. Yes. Now we are ready to derive this. In fact, all this was a preparation to derive this. Now let's first consider the right triangle. In right triangle QTP, let's consider the triangle QTP. So let's take sine theta here, because there is sine theta. Let's take sine theta here. In general, sine is opposite by hypotenuse. For this triangle, opposite to this angle theta is QT, by the hypotenuse, which is opposite to this right angle, is QP. Q2 I'll write as it is. As I told before, QP is representing the vector B, and the length of QP will give us the magnitude of vector B. So therefore QP I will write as B, which is the magnitude of vector B. So from this, if I cross multiply, so B sine theta will be equal to QT, or QT will be equal to B sine theta. Let's call this as equation 1. Now let's take the same I will take another right angle triangle, so where QT is involved. And what is that right angle triangle where QT is involved? We'll take it as QTO. So in right triangle QTO, so what is the angle that is involved here? Alpha is the angle that is involved in this right angle triangle QTO. Let's take sine alpha. Why? Because there is sine alpha here. So sine alpha, opposite to this angle alpha, is this QT, by what is this? It is OQ. OQ is the hypotenuse of this triangle QTO, as it is opposite to this right angle QTO. So therefore OQ is the hypotenuse. Now this QT I'll write as it is. What is OQ? OQ is the diagonal of this parallelogram, and as per a law called as law of parallelogram vector addition, the length of the diagonal will give us the magnitude of the resultant vector, and the magnitude of the resultant vector, let's represent it by letter R. So R is the magnitude of the resultant vector R. So I'll write R here. Now if again cross multiplying, we can say that QT is equal to R into sine alpha, that is R sine alpha. Let's call this as equation 2. Now it's time to compare equation 1 and equation 2. So from equations 1 and 2, you observe that the LHS of equation 1 is equal to LHS of equation 2. So we can equate the RHS of equation 1 and equation 2. So that is B sine theta is equal to R sine alpha. I'm equating the RHS of equation 1 with the RHS of equation 2. Now let us write this equation in a ratio form or in proportion form. So how do we do that? So I'll rewrite this. B sine theta is equal to R sine alpha is what we have got now. Yeah, this one. Yes, I'm writing this. So I'll retain B here, and here sine alpha, it is multiplied to R, and if I bring it to the LHS, this multiplication becomes division. So B by sine alpha is equal to R by, here it is multiplication, so if I transpose it, it becomes sine theta. B by sine alpha is equal to R by sine theta. Let's call this as equation 3. Now we have actually partially derived this. B by sin alpha is equal to r by sin theta. B by sin alpha is equal to r by sin theta. We have partially derived. What is that we need is, we need to somehow prove that these two are equal to a by sin beta. For that, let's take the help of some more constructions. And what are the constructions which we must do? Draw let's draw PM perpendicular to OQ. Draw PM perpendicular to OQ. Now let's take the triangle PMO. In right triangle PMO. So now the angle, I told you this angle is alpha. In fact, this angle is same as this angle, and it is alpha here. Let's use sine alpha because there is sine alpha here. So sine alpha, in general, sine is opposite to this angle alpha is PM by hypotenuse. In this triangle PMO, OP will be the hypotenuse, as it is opposite to this right angle triangle OMP. How is this 90 degrees? I already told, we have to draw PM perpendicular to OQ. Right. So what is the hypotenuse? It is OP. So I'll write OP here. Now this is PM. What is OP? OP is representing the length of this side OP. Length of side OP gives us the magnitude of vector A. So I'll write A here. So instead of OP, I'm writing A. A is the magnitude of vector A. Now cross multiply. If you, PM will be equal to A sin alpha. PM is equal to A sin alpha. Let's call this as equation 4. Now we will take another right angle triangle where PM is involved. So in right triangle, so what is that? Another right angle triangle where PM is present. So PMQ. So now because we have sine beta here, and beta is part of this triangle PMQ, let's take sine beta. So sine beta, that is opposite of this beta is PM, and because this is a right angle, opposite to this right angle is the hypotenuse, and that is PQ. PM will write as it is, and PQ is nothing but it is representing the magnitude of vector B, as we discussed before. So I shall write this PQ as B, the magnitude of vector B. Now cross multiply this, so we'll get PM is equal to B sin beta. Now compare equation 4 and 5. From equations 4 and 5, so we can see that the LHS of equation 4 and 5 are equal. So A sin alpha will be equal to B sin beta. So this is, be careful with B and beta. So now let me write this in proportion form or equalities of ratio. So A, this beta, which is sin beta, which is multiplied to B, I shall take it to the LHS. It becomes divided by like this, and this is B sin alpha, which is multiplied to A. If I transpose it to the RHS, it becomes divided by sin alpha. Let's call this as equation 6. Now it's time to compare equation 3 and equation 6. Equation 3, this equation, and equation 6. So from equations 3 and 6, so you observe carefully, what is that which is common between equation 3 and 6? It is B by sin alpha. This B by sin alpha is equal to A by sin beta, and this is as per equation 6, and this b by sine alpha is equal to r by sine theta from equation 3. So if we rewrite this, first I shall write r by sine theta, then I shall write this a by sine beta, and then that is b by sine alpha, and this is what we were supposed to derive. You can check. Law of cosines is r by sine theta is equal to a by sine beta, that is equal to b by sine alpha. Here that is what we have derived. You can compare this with this. So we have completed the derivation. In this way we will be able to derive the mathematical law of sines. Here we have used a law of addition of vectors called parallelogram law of vector addition. So please subscribe, like and share. Thank you for watching. Please do not forget to subscribe, like and share. Let these videos reach many more students and help in their preparation for their examinations. Thank you very much.